I want to rearrange this problem as we started off and pretend that this thing in the middle here, this argument, is an angle, because that's what arc tangents will give us, or any arc function for that matter. I'm going to say phi equals arc tangent of 5x. And now let's rearrange that to say tangent of phi equals 5x. Okay? Now what that does for me is I can now write the original question in terms of this. Okay, so I'm going to say tangent of phi is 5x. What is sine of phi? And all we have to do to figure this one out, this may look more familiar to you, is imagine a triangle whose tangent is 5x. So I'm going to draw a triangle in quadrant 1. I don't have any reason to suspect a different quadrant for this one. I'm not told that there's any negative signs. So I'm going to say quadrant 1. And there's my opposite over adjacent sides, 5x over 1. That's my 5x. So if here's my phi angle, you can see that the tangent of phi, if you think of SOHCAHTOA, is definitely 5x over 1, the way I've constructed this. So that's my initial condition. Now let's use Pythagorean's theorem to figure out what is the hypotenuse of this triangle. So we're going to call this 5x, and watch out for that squared. We'll get to that in a moment. 5x squared plus 1 squared equals the hypotenuse squared. And this might be a common mistake right here. Make sure you square both the 5 and the x. So we get 25x squared plus 1 equals c squared. And then this becomes the square root of 25x squared plus 1. So that's my hypotenuse. It's this kind of ugly square root thing. So square root of 25x squared plus 1. And now back to our original question, what is sine of phi? Well, let's give me a little room here. Sine of phi is going to be opposite over hypotenuse, which in our figure here is going to be 5x is the opposite side from that angle, and the hypotenuse is this square root function that I have, which is 25x squared plus 1. So that's how you work your way through this problem. It's more of a matter of rearranging the initial question right here into something that you might recognize better from earlier units in trigonometry. Watch out for domain restrictions. This one doesn't seem to have any. But if it were asking you, for example, what's the domain, this problem is not, but what if it were? What you would need to look for is domain restrictions of the denominator. Okay, or of the square root. Both of those can generate domain restrictions. In this case, there's no way that square root is going to be the square root of a negative, right? 25x squared plus 1 is always positive, so that's fine. And 25x squared plus 1 is always bigger than, is never 0. So we're pretty good there. There's not going to be any domain restrictions. That means we're going from negative infinity to positive infinity. But you could very well have a problem where your final function has possible domain restrictions in it, in which case you want to be careful to list those in your domain.